Elvis Andrews hits the ball with an initial velocity of 103 feet per second in the direction of a 10-foot fence that is 300 feet from home plate. The ball leaves the bat at an angle of 35 degrees and at a height of 3 feet. Will the ball clear the fence and be a home run? Question mark. Let's find out. Start with your velocity, t, and then the angle, which was 35 degrees. Whoop, don't forget cosine, sorry. Sine 35 minus 16t squared, and he hit the ball at a height of 3 feet. So we're going to add 3 feet there. Okay, was it asking, will the ball clear the fence and be a home run? Well, let's figure out how long it's going to take the ball to reach the fence. So we're going to take the x portion of our parametric equation here. We're going to set it equal to 300. And then divide both sides by 103 cosine 35. Like it's going to take 3.556 seconds to reach the fence. And what I'm going to do is I'm going to plug this equation, the y equals portion of our parametric equation, into my calculator here. Let's graph it. That looks to be about right. And now we're going to solve for 3.556 by hitting second table. 3.556, enter. Second graph. Looks like at 3.556 seconds, the ball will be 10.761 feet off the ground. So will the ball clear the fence and be a home run? Yes, it will, because the fence is 10 feet high. So I guess your answer to this is yes. Example 10, we have a little misprint here from number 8, they meant 9. Assume there is a wind of 22 feet per second blowing against the ball. Will it clear the fence now? We remember how we had to set this equation equal to 300 to see what time it would reach the fence. Well, we still want to use that 103t cosine 35, but now we have wind blowing against the ball, so we need to account for that. And if the ball is blowing at 22 feet per second, we would say 22 t cosine, the wind is blowing against the ball, so that's going to be a 180-degree rotation. And now we set that equal to 300. But Mr. Flores, why is it 180? Why, I'm so glad you asked that. That's a very good question. Here's a coordinate plane. We hit the ball this way. Pew, boop. The wind is blowing in the opposite direction, horizontal to the path of the ball. So the wind's blowing this way. And do you remember, if our wind is blowing this direction, here's our terminal point here. If I start from the positive x-axis and rotate until I hit the terminal ray, I have just completed a 180-degree rotation. That's why it's 180. Okay, so now in order to solve, we're going to factor out a t, leaving us with 103 cosine 35 plus 22 cosine 80. Set that equal to 300. And simply divide both sides by what you have in parentheses there. Looks like now that the wind is a factor, it's going to take 4.810 seconds to reach the fence. We're still going to use the exact same y equals portion of our parametric equation here, which we have already plugged in our calculator, remember? So now we just have to solve for 4.810 by going to second window. 4.810, enter, second graph. Looks like at 4.81 seconds, the ball will be negative 83.01. Well, that's not greater than 10 feet. Therefore, the answer to this question is no, it's not going to clear the fence this time. Example 11, we have another misprint from number 8. That should be 9. Assume that there is a wind of 22 feet per second blowing with the ball. Will it clear the fence? Let me draw you another diagram. This is the direction we hit the ball. Pew, boop. This time the wind's blowing with the ball. And if we have a terminal ray that is pointed this direction, and we didn't make any rotation at all, that is a 0-degree rotation. So we still need to use this x equals portion of our parametric equation first, or second, it really doesn't matter. And now let's add the wind that's blowing with the ball, 22 feet per second. And then 0 equals 300. Factor out a t. Divide both sides by what we have in parentheses there. Now that the wind is blowing with the ball, it will take 2.820 seconds. Second table, or second window. 2.820 second graph. Looks like now that the wind is blowing with the ball, by the time the ball reaches the fence, which is 10 feet high, the ball will be 42.363 feet above the ground. So, will it clear the fence now? Yes. Example 12. Here's how you do it. You don't worry about it. Okay, once you read through 13, which there's a lot there, I'm just going to go ahead and break it down and tell you what we're looking for. Okay, I went ahead and set up the component vectors there. We're trying to figure out what is the height at 420 feet. 420 feet, that's the distance of the wall that he hit the ball to. Is it a home run? Yes or no? And what is the total distance of the ball? So let's first figure out what is the height once the ball reaches 420 feet. In order to do that, let me section this off just a little bit. We're going to take the x portion of our parametric equation here. And set it equal to the distance of the fence. Then divide both sides by 155 cosine 22. And then calculator. It's like it is going to reach the fence, the time it takes to reach the fence is 2.922 seconds. Now that we know when it will reach the fence, we can figure out what the height is at that particular time. So I'm going to go to the y equals portion in my calculator, clear out the previous data, and now I'm going to input the y equals portion of our parametric equation here. I like to look at the graph first. It gives me an idea if I may have done something wrong. That appears to be about right. So now second window, 2.922. Enter. Second graph. Looks like when the ball reaches the fence, it will be 36.054 feet in the air. Meaning that, yes, it is a home run. Now to find total distance, what we're going to do is we're going to go back to our graph here. And we're going to find the zero. When does it hit the ground? So this graph goes through the x-intercept between the x-intercepts of, well, there's 1, there's 2, there's 3, and 4. So it looks like it falls between 3 and 4. Second trace. 3, enter, 4, enter, enter. Looks like it's going to hit the ground at 3.6799 seconds. So we're going to round that up to 3.680. Now, to figure out, well, now that we know when it's going to hit the ground, we can figure out where, or total distance it traveled, by plugging it into this equation here. Looks like Hank hit this ball 528.866 feet. Wow. And you're done.